the study of rocks. Although you think of a rock as a boring nugget of stone that you might skip across a pond or kick across a sidewalk, a rock is much more interesting than you might think. The rocks on Earth tell an exciting story, but in order to understand that story, you need to learn a little about chemistry and physics first. Chemistry is the study of matter. So what in the heck is matter? It's anything that has mass, or also called weight, and it takes up space. So the air in a balloon? Matter. The shady tree in your backyard? Matter. Your favorite lemonade? Matter. So the question really is, what is not matter? Energy is not matter. Heat is not matter. Sound is not matter. Light is not matter. Those things are energy. And think about it. They don't have mass, and they don't take up space. In other words, you can't collect them up and sit them on a scale. It would be impossible to corral light waves into a room and pack them up in a box. So, chemistry is the study of matter, and rocks are matter. That means, like all other matter, rocks are made of tiny pieces called atoms, and rocks can melt or freeze or even vaporize if the temperature is hot enough. Physics is the study of how matter moves or does not move. For example, engineers use their understanding of physics to build bridges that don't collapse from the weight of the cars that drive over them. Doctors apply their understanding of physics to build casts that keep broken bones from moving. Detectives use physics to determine the speed and direction of the cars that are involved in a crash. Understanding how and when matter moves makes our lives so much easier. But when it comes to studying rocks, physics tells a very interesting story. A story that is almost as old as time. When Earth first formed about 4.5 billion years ago, everything was a liquid. But as things cooled down, a solid crust formed all the way around the Earth. Scientists have literally named this the crust. Under the crust, molten rocks called magma formed convection currents, which just means that the liquid was moving around. As time passed, the crust broke into pieces, and the heaviest parts, made of a very dense rock called basalt, sunk to the bottom layer of the crust, and the lighter chunks floated on the top of the crust. The heavy rock called basalt is also called oceanic crust because it is actually at the very bottom of most of the oceans. It's under the continents too, but on the continents we have additional layers of crust and dirt that cover the basalt. This is called continental crust. The chunks of oceanic and continental crust are called tectonic plates. These plates float on the surface of the Earth because they are both lighter and less dense than the magma inside the Earth. And since the continental crust is lighter than the oceanic crust, it floats on the very outer surface of our planet. These floating pieces of crust move around the Earth due to the convection currents underneath. But it's a very slow movement. A plate can only move about 1 inch a year. As you can imagine, sometimes the plates collide, and that's where the fun begins. These collisions are part of the rock cycle. The rock cycle forms new and different rocks, and the collisions between tectonic plates form mountains, valleys, and volcanoes, and they are 100% responsible for earthquakes. They say you shouldn't judge a book by its cover, and the same goes for rocks. So the next time you pick up a rock, I hope you take your time with it so you can understand the story it carries along with it.